Hello, Amira.
Hello,
How are you?
how are you?
I'm good, thank you. How are you?
Yeah, I'm good.
So, are you preparing for your school or still you're in the mode of holiday?
No, I'm preparing for school.
How are you preparing? Mentally, physically, spiritually?
Um, all of them.
That's good. So, you'll go to the same school, right?
Mm-hmm.
Very good. So, your school opens September 7th, right? Next week.
Yeah.
Next week? Yeah.
No.
Yeah, after next week, one more week. Good. So, Amira, what are we doing today? Number one is we need to finish chapter 1. The last time we were solving about problems, right, related to quadratic equations.
Mm-hmm.
And let me just see what you have done. And after that, maybe I will show you some examples related to circle. It's about coordinate geometry and practice a few questions. And also we will try to finish that chapter 3. And still, if we have time, we will start chapter 4. That is about
Okay.
matrices. Okay, that is what we are going to do today. So Amir, let's start with those problems. And
Okay.
okay, let me just allow you to share. Do you still have that file? Did you solve it there or in
Yeah,
the paper? How did you
I
solve?
did it on the file.
Very good. Let's have a quick look at those questions. And
So it was starting with this one.
so we stopped here, 98.
Yeah, we did this together.
Okay. So 98, all right. So here, no question, right? I think everything is clear. 99. Okay, what is it? The hypotenuse of a right angle triangle is the perimeter between the 17.
So these are the two lengths.
The right angle triangle. Okay, good.
And this one I didn't understand.
A path 1.6 meters wide surrounds a circular pond, and the area of the path is 1/3 that of the pond. Find the radius of the pond. Correct to decimal places. Okay, but you understood the question, right?
Yeah, but I didn't know where to start from.
Yes.
And then there's this one that I did.
What happened? On 101?
Yeah, so I got this as my answer.
So it's no problem.
Yeah, and same with this one.
102, okay.
And then this one I didn't understand either, so this is the last one.
Okay, 103.
I didn't understand the question.
Okay. So, question, the previous one, what was it? 101 or 100? What was the question number?
100.
Hundreds and 103. Okay then, Amira, let's solve these questions together and finish this chapter then. Okay, let me share. All right. Okay. Okay. This question, right? 100. All right.
Yeah.
Good. Yeah, because if I just write on the screen, then we cannot save this. But here, at least I can save and after that share with you. That's much better. So in this question, a path 1.6 meters wide surrounds a circular pond. Okay, and the area of the path is 1/3 that of the pond. So here we have a pond. Okay, and around this pond we have a, what is that? Path, kind of path, a small path. Okay, and the width of this path is 1.6 meters. Okay, and the area of the path is 1/3 that of the pond. Okay, that means that let me just shade this path. So we are talking about this, and here let's say the radius of the small circle is R, and the big one is, let's say, capital R, right? So it says that the area of the shaded region, right, is 1/3 that of the pond. That is 1/3 of, let's say, this circle. Okay, it means this, right? So a path 1.6 meters wide, and the area of the path, actually should just not as here, the area of this shaded part, that is path, is equal to 1/3 that of the pond. So this one is the area of the path, and this one is the area of the pond. Let me just write here P. And it says that here the width of the pond is 1.6 meters, right? So number one is we can write the relationship between how these two radii are connected to each other. So since this one is 1.6, right, then capital R is equal to R plus 1.6, right?
Okay.
And from here, shaded region, what is it? It is just pi times capital R squared. 1/3 times, how about the pond? It is pi times R squared, radius of this. Now we know what is capital R, substitute here. Pi cancels each other, multiply both sides by 3. So here we have 3 times capital R squared, that is R plus 1.6 squared equals R squared.
Okay.
Okay.
Mhm.
Now from here, how can we continue? What is the next step here, Amira? I mean, how would you solve this equation?
I would just uh hmm.
I mean, what is the quickest way to solve this equation?
Um, if you do like three times everything in the brackets.
Here we have something like this, right? If you just look at this side, I can bring this 3 inside, right?
Yeah.
So here we have something like this. Here we have x squared is equal to a squared. If it is different form, then we can use a formula and other methods. But if the equation in this part, then we know that the solution will be that x will be plus minus a. So what we have here, we have square root of 3 times r plus 1.6, right? And here we have whole squared, that's equal to r squared. So when it is negative, actually it will be negative, so we should just take only positive 1. From here, square root of 3 times r plus 1.6, that's equal to, on the right hand side, we have r. So this one is much faster way. As you see here, just we need to solve here linear equation. We don't have quadratic. Why I didn't take the -1, I can write this. Here, the second one is minus a, that is minus r. At the time, that answer will be negative. And since here we are talking about the length, so we should take only positive answer. Now from here, as you see, if you just remove the brackets and take this r to the left-hand side, we have here square root of 3 minus 1 times r. On the right-hand side, it will be minus. Is it?
Okay.
Okay. So that's the first answer. Here we have minus square root of 3 times 1.6. And second one is we should take the square root of 3 times r plus 1.6. That's equal to negative r. I think in the second part we will have positive answer because here it is negative. So it's rejected. Anyway, actually, even you don't try this way, you know how to solve any kind of quadratic equation. The important thing is to be able to write this equation, right? How actually these things are connected. And here the question is, what is it? Find the radius of the point. Actually, we need to find r. If you just solve this equation, we will get what is r. Okay, right? It's clear.
Yeah.
Good. And the last question, 103. A room 24 meters by 18 meters is covered with ceramic tiles so that a border of uncovered floor of uniform width is left only. Okay, if the area is becoming it's also a very similar question, but here it's not a circle, it is rectangle. So we are talking about a room. Just imagine it's your room and you are going to change this floor cover, like maybe you're going to change this with some kind of ceramic tiles. And the length of the room is 24 meters by 18 meters. And you're not going to cover the whole floor. And you're going to just leave some space open near the wall, under the wall. So we are going to cover this part with ceramics. Okay. So cover with ceramic tiles so that a border of uncovered floor of uniform width is left all around. Okay, that's uniform. This one, let's say it is X. Also this width is X. And also this one is X. And also this one is X. And this part is covered with ceramic tiles. If the area of ceramic tiles at the center of the room is 408. So let's say that area is capital A. And how do you find the area? It's just a rectangle. It is length times width, right? And since the length of the room is 24, and here we'll have some space empty, right? Also here, uncovered. So the length of this covered part will be 24 minus 2x, right? So here we have 24 minus 2x times. And how about the width? It is 18 minus x and minus x. So that is 18 minus 2x. So this area is equal to 108. It says that that's covered part is equal to 408, right?
Mm-hmm.
Now it's just a quadratic equation again. And
Yeah.
if you just expand this and you'll get the answer. And here the important thing is to understand the problem. As you see, once you understand the problem, and the rest is, and after the, of course, after introducing a suitable variable, write your equation, and the rest is just using that fixed rules, we can get the answer. Okay?
Okay. Yeah.
So we are going to finish this chapter then. Let me close it. Okay. Amira, about coordinate geometry, we talked a few things, right? Actually, that much is enough. Now, if you just learn a bit deeper, that much knowledge is enough to take any university course related to coordinate geometry. And of course, you need to practice some different problems. And here we have one more thing is left, that is about a circle. I mean, circle in coordinate geometry. And if you remember in our first class, when we actually met with your parents and I gave you a sample lesson, we talked about this thing. And once again, quickly, we're going to have a look and saw a few examples. And after that, I will ask a few questions. I mean, I prepared questions for you and you're going to solve this. In this way, we will finish this chapter.
Okay.
So since we are talking about a circle, and when we just ask what is a circle to students, aircon is too cold here. Okay. So people answer like it's a round shape, it is something like this, it is something like this, blah, 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 this kind of answers. Because in kindergarten, when you're teaching circle to students, we say that a round shape. And for example, the wheel of a car, for example, the wheel of a bicycle, and this kind of example, that's good. And how about the geometric definition of a circle? As see, when you are defining this, we just define as the collection of infinitely many points. We have a lot of points, but it's not countable, it's too many, and which are equidistant from a fixed point. We are doing everything on a plane, right? Because when you talk about geometry, three things are the most important things. I mean, the concepts, or let's say terminologies. Number one is point, number two is line, number three is plane. And everything is done with these three things. It's like cells of human body. Anyway, so that is our circle. All the points equidistant from a fixed point. We are just fixing a point, and after that marking all the points which are equidistant from this point. And that thing, whatever we get here, that figure is called a circle. A fixed point, we call this a radius, right? And the distance from that fixed point to any point on the circle, we call this a radius. And any point, if you just join any point on the circle with another point on the circle, let's say this one, we call this chord. And the longest chord of a circle is a diameter, which passes through the center. Anyway, these are just information. Now we will talk about the equation of a circle in coordinate geometry. And also, if you remember, actually, we have already talked this. Just to remember this, I'm going to give you this idea once again. So that is a plane, as you see here in the previous one. When you just look at the circle, okay, what is this point? Okay, here it is somewhere here. You need to show with your pencil or something, right? And what is the radius? Okay, you're just measuring because you need to put your ruler, and the only way is this. Put your ruler and measure this. I can tell you, okay, the radius of the circle is 5 and the diameter is 10. And after that, we can find the circumference or area. But if we introduce two lines here, one is horizontal line, and second one is vertical line, as those are actually our x-axis and y-axis. Let's see here, I don't know, things actually get very, very beautiful for me, because sometimes when you just look some notations, one thing is, for example, let's say limit of something here, when x approaches, for example, 0, that's equal to 5. I don't know if you have ever seen this. Did you ever see this limit notation, Amira?
No.
No?
Mm-mm.
Maybe you'll see in grade 11 or 12 or at university. Anyway, it is something like this. And I say that, okay, this is very, very fancy notation, so beautiful. And students ask, what is beautiful here? And if I just tell you something, when x approaches 0, the value of 5, actually, the value of the function equals 5, this is how we explain this thing. But if I tell you this statement, how would you notate this, or you express this using algebraic notations? If you just sit and think about this, it's really, really difficult task. Anyway, that's not what we are going to do here. For me, what I'm trying to say here is just a plane, as you see here, by introducing two lines, that is x-axis and y-axis, things change dramatically. I mean, everything gets beautiful form. So now we know exactly where is the location of it is center and all the points of the circle, and I can describe with algebraic equation, and after that I can find it is radius without measuring this. Just what we have to know here is it is center. Anyway, so now our first task is, if we are given the center of the circle and if we know the radius of the circle, the question is, how can we write the equation of the circle? Actually, this is how mathematicians were interested in writing the equation of the circle, anything, any graph. But here we will just use the idea of a distance. In a coordinate system, we know that if you're given any 2 points, we know how to calculate the distance between those 2 points. Now that is fixed point, whose coordinates are h and k, x coordinate h, y coordinate k. And to represent a circle, let's just denote any point on the circle by x and y. And why we are using x and y? Because they are variable. It can be this point, it can be this point, it can be this point. So if you find the distance, also it's given that r, so the radius squared will be equal to, what is it here, x minus h squared plus y minus k squared. Actually, all the points or x and y's which satisfy this equation, that means that it is on the circle. It is a point on the circle. And we say that this is the equation of a circle whose center is at hk at this point and whose radius is r, right? And after that, if you just expand this, we can get different form of the circle. How is it? If you just expand the right hand side, what do I get here? We get here x squared minus 2 times hx plus h squared plus y squared minus 2 times ky plus k squared. Now on the right hand side here we have r squared. And that's just a constant number. That's a constant number. I can just denote this by some kind of letter and some kind of letter. I can just write it as x squared plus ax plus y squared plus by. This one y squared, this by. And here we have everything here. A squared plus k squared minus r squared. Let's say it is c. That's equal to 0. So immediately if you see any equation in this form, here we have y squared. And from here we can see that actually this describes a kind of circle. That is the equation of a circle. Any equation of this form, or either this form or this form. That's all about the circle actually in a coordinate system. Okay, I will stop here. Here we have 3 examples and you are going to solve them. Also practice for you. I know you have PowerPoint, right?
Yeah.
So can you open the file I'm sending you now? Okay. Slideshow. Okay. I mean, here you don't have to go into details, but just here, write in the equation in the form that x minus something squared plus y minus something squared equals radius. That much is enough. So find the equation of the circle with center 2, 3, and radius 5. So quickly, what you have to write here first is write that formula, and also, of course, we don't have to memorize, but some things, at least if you know how actual things are connected, it helps it to solve the problems faster. So that is 2, 3, and the radius is 5. Okay. So what is the equation of the circle? The center is 2 and 3, right? So it is x minus 2 squared plus y minus 3 squared equals 5 squared, radius squared.
Wait, what's x again?
X?
Yeah.
What x?
What is x again? Like what's the value of x?
No, that's this x represents x coordinate of any point on the circle, right? So it is variable here. So you are just putting something into this equation, right? H minus x minus h squared plus y minus k squared equals r squared. Okay, that's it. Now, later we can continue depending on the question. So that is the equation of the circle. So what is x and y? These are the coordinates of any point on the circle, right? That satisfies this equation. If you just find any pair of numbers for x and y, if you substitute here, evaluate this, if it is equal to the right-hand side, that means that that point is on the circle. If it doesn't satisfy this equation, it means that that point is not on the circle, somewhere else. It means this. Okay, let's move to the next question. Next. Okay. Can you read the question?
Find the equation of a circle with diameter AB where AB have coordinates 4, -3, and 2, 1 respectively.
Okay.
Do we need to work out the diameter first?
Yeah, actually, as you know, in the equation, right, to be able to write, to write the equation of a circle, we need two pieces of information. Number one is we need to know its center, coordinates of the center. Number two is radius. So since it's a diameter, its midpoint gives us the center of the circle, right? So using the midpoint, let's find its center. And after that, you will find its radius. And step number 3, we will write its equation. Let's say step number 1. Yeah, here, what are we trying to do here? Is here, let's say it is O, right? We are trying to find the coordinates of O, the center. Are you thinking or?
Yeah, I'm thinking.
Thinking what to do or how to do?
What to do.
Really? Are you serious?
Yeah.
Okay, I'm gonna here. So first, when you read the question, actually we should know what we are trying to do here. We are going to write this equation, right, for the circle, that x minus h squared plus y minus k squared equals r squared. To write this equation, okay, this x and y is a variable in this equation. So we need to know this h, and that's k, and also here r. What is h and k? These are the coordinates of O, right? And since AB is a diameter and O is a center, so the center is the midpoint of A and B, right? So, and how do you find the midpoint of A and B? Then coordinates of A, okay.
Oh, wait, I didn't mean to write that.
Yeah, can you write with comma? Or maybe on the left hand side, you can just write O. So we know what you're trying to find here. So 4 plus 2, it is 3, okay.
Did I do it? Did I do it correctly?
Yeah.
Okay.
And also doing this one, Amira, can you also label this? So if you just label here the center with O and write here O equals, I can see what you're trying to hear.
Okay, so we know
the center, right? That is H and K. Okay. No, you don't have to write H and K there. Just write O, that's enough. Capital O. Yeah. Okay. Now next step is let's find the radius. Number 2, step number 2.
How do we do how do we work out the radius?
Yeah, that's why if you label here, you can see this. So that's the center, right? So this one is, these actual two things are equal. So let's say this one is R and also this is R, right? So what is the radius then? The radius equals either take this AO or OB. Which one actually better for you, right? And we know the coordinates of O, we know the coordinates of B, so we know how to find the distance between 2 points, right? So it gives us the radius. OB, for example, what is OB? The coordinates of B, it is, let's say, 2, 1, right? So here we have 3 minus 2 squared plus, and here we have -1 minus 1 squared. So that's equal to, it's 1, 2, 5, square root of 5, something like this.
Okay, so that's the radius.
Yeah, that's the radius of the circle. So now we have everything to write the equation of the circle. We know the radius, we know the coordinates of its center. So now we need to write the equation. X.
Oh, x, yeah.
X minus X coordinates.
Oh.
Okay.
Is that it?
Yeah. Maybe in the next step we can simplify this, but you don't have to do this because minus minus 1 is just plus, right? It's y plus 1 squared.
Yeah.
Okay. I mean, let's move to the next question. If you just get some ideas and you can practice later. And here, important thing is how we should solve those problems, the methods.
Find the center and radius of the circle 2x squared plus 2y squared minus 3x plus 4y plus 1 is equal to 0.
Okay.
Yeah.
So how do you, solve this question?
We work out what x and y are.
How?
Not sure.
Actually, question says, the question is here, find the center. It means the coordinates of the center and radius of the circle, right? So we need to find this O and we need to find, what is it? R. So to answer this question, so that is R, if we can actually transform this equation into this form, right? That is x minus h squared plus y minus k squared equals, here we have r squared, right? And after that, we know that here h and k, these are the coordinates of the center. And here radius of the circle is just r. So can you write this equation in this form? And after that, we can answer the question, right? Is it understood or?
I think so.
Okay. It's just like completing this the square, like in the first chapter. So here we have two perfect squares, right, in the expression. One is in x, another one is in y.
Yeah.
Okay, let's do it. Are you thinking, Amira, or
Yeah, I'm thinking.
thinking about what?
The steps.
Okay, in the first step, just regroup. First, write everything in terms of x, and after that, in terms of y. And take the constant to the right-hand side. Because here, what we are going to do here is, we are going to write this expression in this form, right? Here we have x minus h squared plus y minus k squared, and here we have r squared. So here we need to have a perfect square. Here we need to have a perfect square here and a constant. So I see here we have x, here we have 3x. So I need to write here first, here we have 2x squared minus 3x. Then here we have y squared, and here we have y. So I will write y expressions here, 2y squared plus 4y. And let me just write 1 on the right hand side. So now if you divide both sides by 2, because we have perfect square here, the coefficient of x must be 1. So here we have 2. So we need to eliminate this 2. The same thing here. So if you divide both sides by 2, here we will have x squared minus 3 over 2x plus y squared plus 2y is equal to minus 1 over 2, right? As you see here in the first part, here we have x squared minus 2 times 3 over 4x. Because in the formula we have 2, right? If we expand this, here we have minus 2hx. That's why we need to write 2 here. And plus, I need something here. So here we have y squared plus 2 times 1 times y. And also I need something here. On the right hand side, we have negative 1 over 2. So what I need here, so that I can write the first three terms as here, like this, as a perfect square, as the square of this algebraic expression. So I need the square of this number, right? 3 over 4. So I add 3 over 4 squared to both sides. Here we have plus 3 over 4 squared. And how about for y expression? We have 2 in the formula, and y squared, so we need 1 squared. So I add 1 squared to both sides. Now, if you notice here we have perfect square. Something is squared, a squared minus 2 times a times b plus b squared. So we can write it as x minus 3 over 4 squared plus, and how about here? It is y plus 1 squared, right?
Okay. Yeah.
And just simplify this, it gives us r squared. So that is, whatever it is, half, I think. It is 16. It is 8. 8 plus 9, I think 17 over 16. And now we can write what are the coordinates of the center of the circle. So it is minus 3 over 4, 3 over 4, and y minus 1. And how about the radius? Radius is square root of 17 over 4.
Okay.
Okay?
That makes more sense. Yeah.
Good. Then let's move to the next question, because later also you will solve this here. I just actually, these questions, the diagram was not given. I just drew this for you so that you can understand faster and we don't waste time. Find the equation of the circle which passes through the points 5, 0. Can you label this A, Amira, on the diagram? Where is A? 5, 0. On the x-axis, right? On the x-axis.
Oh, on the x-axis. Wait, does it? Hold on.
Yeah, actually here I need to write y and x. Okay, 5, 0. That means x coordinate is 5, y coordinate is 0. Okay, that's A. Let's just label A. Okay, B, 3, 4. It is somewhere on the circle. You can also label this there, somewhere there. 3, 4. Okay. And has its center lying on the line. Okay, that is 2y plus x equals 4. So the question is, we need to find the equation of the circle, right?
Yeah.
Again, I mean, immediately, actually, all these questions are the same. To be able to write the equation of the circle, again, we need two pieces of information. Number one is center. Number two is radius. Because if I know these two information, I can actually form a circle. It's like a line. For also to draw a line, we need two pieces of information, right? Either 2 points or 1 point and its slope, right? So it's something like this. So now number one is you need to find its radius, right? And number two is we need to find the coordinates of its center. Now, second step. And third step, we will write the equation of the circle. Okay, then number one is how do we write? I mean, how do you find the radius of the circle?
If we work out like this length, maybe. We could work out the radius after that. Right? Or is that wrong?
Can you just put capital O for the center? Let's say this O. Now, what are the coordinates of O? Center.
We don't know that, do we?
Yeah, we don't know. That's why we cannot find R from here. But can you also draw another radius that connects O and A? Oops. Where's your circle? Okay. Okay. My question for you, Amira, here it says that it's center lying on the line. How can we use this information?
Not sure.
Okay, I mean, now I will show you. Maybe in the other question you will solve this. This is a little bit challenging problem because you need to make use of this information. It says that the center of the circle is lying on this line. Let's solve this question. After that, you'll have a break. And so that is O. So its coordinates are, let's say, X and Y, right? Since this point is on this line, it must satisfy this equation. From this equation, I can write y in terms of x. How? This y is equal to 4 minus x over 2, right? Because it shows how x and y are connected to each other. From here, 4 minus x over 2. So here, instead of y, I can write actually this expression in x. So that is 4 minus x over 2. And since the point A and point B on the circle, right? So if you just join them, OB and OA. So this radius is equal to OA, at the same time, OB. So now for OA, what is OA? OA is the distance between O and A. So that's equal to, what is it? X1 minus X2. X coordinate of O is X. So X coordinate of A is 5. So here we have X minus 5 squared. And how about Y coordinate of O? That is 4 minus X over 2 minus Y coordinate of A. It is 0. So here we have this thing squared. In a similar way, how about if you evaluate this OB, that the distance between O and B, x coordinate of O, that is x, so here we have x minus 3 squared, plus y coordinate is 4 minus x over 2, minus y coordinate of B is, it is 4. So that is 4 squared, right? So since OA and OB, they are equal to each other and they are both positive and also their squares are equal. That means that this expression inside the bracket, that is x minus 5 squared plus 4 minus x over 2 squared is equal to this thing. That is x minus 3 squared plus 4 minus x over 2 minus 4 squared.
Okay.
So if we solve this, we know how to solve this. We can get the value of x. If I substitute here, we will get x coordinate and y coordinate of the center of the circle. And if you just substitute either in the first equation or second equation, we will get the radius of the circle. And after that, using this information, we can write the equation of the circle. Okay? Good. Amir, it is 5:18. Have some rest, okay? After 12 minutes, we will continue. Okay?
Okay. Yeah.
Okay. See you soon.